Alright, so welcome back. Last we left, we're going to multiply this expression by its conjugate to try to simplify the expression and see if we can get rid of the 0 over 0 problem that we had. So the conjugate of root x plus 3 minus root of x plus h plus 3 would basically be the same thing but with a plus sign. And when we have radicals, the good thing about multiplying by conjugate is that the roots disappear, right? So if we multiply this by that, becomes a difference of squares, so it becomes root x plus 3 squared which would just be x plus 3, and then it would be minus x root of x plus h plus 3 squared, which would just be x plus h plus 3. Okay, and then on the bottom we have h being multiplied by bracket root of x plus 3 plus root of x plus h plus 3. Okay, now what can happen here is now that we got rid of the radicals, we can now kind of simplify the top a bit. So if we look at the top, still writing as limit as h approaches 0, would have on the top x plus 3 minus x minus h sorry, there should be a big bracket around all of this, so it's minus x minus h, and then that becomes also minus 3, all being divided by, and the bottom doesn't really change much because there's not much to do there, root of x plus 3 plus root of x plus h plus 3. Okay, so on the top here we notice that this x and that x will kind of get rid of each other. This 3 and that minus 3 will get rid of each other. And as I said, you'll end up with an h on the top that can either be factored out or just sort of, in this case, it's just only h. So if we write it out, limit as h approaches 0 of negative h over h times root of x plus 3 plus root x plus h plus 3. Alright, so since this is multiplying here, h times that, this h and that h can cancel each other out, or divide each other out. And what we have simply here is limit as h approaches 0, the top simply becomes minus 1, so there's no more h on the top, and the bottom is just root of x plus 3 plus root of x plus h plus 3. Okay, so since this says the limit as h approaches 0, we can substitute h 0 for h, and here we'd have just x plus 3 rooted. So really what happens here is we have, this would be equal to minus root of x plus 3. So we don't have to write limit anymore because we're going to put in 0 for h. It simply be root x plus 3. Now finally, this would mean that derivative f prime of x would be equal to negative 1 over, that's a root x plus 3, that's the root of x plus 3, so there's two of them, so 2 root x plus 3. And there's the derivative using first principles. Alright, if you wanted to, you could find the derivative using the regular rules that we had before, the power rule, and check to see that this is exactly what you would get. Alright, thank you, and good luck studying for your exam.